Hi everyone, welcome back. On my YouTube channel I have created lots of examples and tutorials on UiPath Studio. I will continue to make more of that, and in addition I am starting tutorials of implementing artificial intelligence and machine learning. Today we will see an example of implementing unsupervised learning model in Python. Now let's get started. Let's begin with an introduction of unsupervised learning and meaning of some terms. Unsupervised learning, also known as unsupervised machine learning, uses machine learning algorithms to analyze and cluster unlabeled datasets. These algorithms discover hidden patterns or data groupings without the need for human intervention. In Python, we will implement a type of hierarchical cluster, which is agglomerative clustering. It is an unsupervised machine learning technique that divides the population into several clusters such that data points in the same cluster are more similar and data points in different clusters are dissimilar. Let's now see what dendrogram is. A dendrogram, a tree-like figure produced by hierarchical clustering, depicts the hierarchical relationships between groups. Individual data points are located at the bottom of the dendrogram, while the largest clusters, which include all the data points, are located at the top. In order to generate different numbers of clusters, the dendrogram can be sliced at various heights. Libraries that we will be using are matplotlib.pyplot is a state-based interface to matplotlib. It provides an implicit MATLAB-like way of plotting. It also opens figures on screen and acts as the figure GUI manager. Pandas reads tabular data format stored as a CSV file into memory by converting it into a data frame. We can use pandas to perform merging, reshaping, joining, and concatenation operations. Numpy is a Python library used for working with arrays. It also has functions for working in domain of linear algebra, Fourier transform, and matrices. Sippy.cluster.hierarchy has features include generating hierarchical clusters from distance matrices, calculating statistics on clusters, cutting linkages to generate flat clusters, and visualizing clusters with dendrograms. Sklern.cluster. Clustering of unlabeled data can be performed with the module sklern.cluster. Prerequisite: a CSV file named shopping_data.csv. Installation of libraries previously mentioned. To download the CSV file, type shopping_data.csv in Google browser. Open the third link as shown and click on download. You need to sign in to download this. I have already downloaded the file, which will be an archive. Copy the archive in the same folder where you will save your code file so that it will easier to read the data from file. Unzip the file to obtain the CSV file in the same folder. Now let's download the libraries. We will use command prompt to download the libraries by using pip command, and by specifying 3 means the version of Python is 3n+. The first one is matplotlib, so the syntax will be pip3 install matplotlib. Next is pip3 install pandas. Next, install numpy by using uflag, which will, if installed, will upgrade it to latest version. Next one is Sippy. For sklearn we have to write skikit-learn. We can check whether the libraries have been successfully installed or not by writing import followed by library name in Python shell. After hitting enter, it should not give an error. As you can see, we have successfully installed all the required libraries, and now we can do the coding part. Open a new file, specify a name, and save it. First, we will import all libraries using syntax as shown. The as keyword is used for aliasing. The from keyword is used to import the specified the function. The function read_CSV with file name inside the round brackets enclosed in quotes from pandas retrieves data in the form of the data frame, which we will store in customer_data variable. Let's analyze our data. To see how many rows and columns are present, let's use shape, which will return tuple of rows, columns of data frame /series. Next, let's use head, which displays the first 5 rows of the data frame by default. Save and run the file using F5. To match the headings with the data, let's go back to the code and add /n, which will add a new line. So here's the total number of rows and columns along with first 5 data of rows. Next, we will select the last 2 columns from our data by using the ilock function. Next, we will specify the size of plot using figSize attribute to specify width and height. Next, let's provide a title. To plot the hierarchical clustering as a dendrogram, cp.cluster.hierarchy.dendrogram function is used. Now, hierarchical clustering requires us to decide on both the distance and linkage method. We will use Euclidean distance and the ward linkage method, which attempts to minimize the variance between clusters. On our created data variable, next specify number of clusters as 5 and remaining 2 same as mentioned previously. Next, we will SEFIT_predict to obtain the labels of the training dataset. Let's specify the size for new figure. Let's plot the scatter plot using scatter function of matplotlib by specifying the x-axis array, y-axis array, color of sequence of colors for markers in color map. To display all the figures, we will use show function. Now let's save and press F5 to display our output. This is the scatter plot. And here is our dendrogram. So that's it for this video. If you found this video helpful, make to hit the like button and subscribe to my channel for more videos on different and interesting learning topics.